Hey, it's Mr. E here, and in this video we're going to cover triangle congruence. But before we get into that, we have to look at some basic definitions. So let's begin with the definition of an angle bisector. An angle bisector divides an angle into two congruent angles. So in our diagram here, we are given that DB bisects angle ABC. That means that DB is dividing angle ABC into two congruent angles, which are angle ABD and angle CBD, these two angles that I labeled with tick marks here. So we can say that angle ABD is congruent to angle CBD, and we could say that because we are told that DB bisects angle ABC, which means it's dividing angle ABC into two congruent angles. Our next definition is the definition of a midpoint. The midpoint of a segment is the point that divides the segment into two congruent segments. So in our diagram here, we are given that M is the midpoint of XY. Given the definition of midpoint here, we can conclude that the segment XM is congruent to the segment MY because M is the midpoint. It's dividing the segment into two congruent segments. So let's write XM is congruent to MY. The next definition is the definition of a segment bisector. So a segment bisector could be a line, a segment, a ray, or a plane that intersects a segment at its midpoint. So in our diagram here, we are given that CD bisects AB. So what that means is that CD is intersecting AB at its midpoint. So that means M is a midpoint. And we already know that if M is the midpoint of AB, it's dividing segment AB into two congruent segments. So AM is congruent to MB. The next definition is the definition of perpendicular lines. So perpendicular lines are lines that intersect and form right angles. The symbol perpendicular that we see here means is perpendicular to. So in our diagram here, we are told that CD is perpendicular to AB. Therefore, we have 90-degree angles here. All right, so here I'm giving you a definition, and it's the definition for congruent. So when two figures are congruent, it means that they are the same size and shape. Therefore, all their corresponding parts are equal. So you could think of congruent figures as duplicates of each other, as photocopies of each other. So we have two congruent figures here, so that means that they are the same shape and the same size. It also means that their corresponding parts are equal. So let's fill in the blanks here. If these two figures are congruent, that means that segment AB or line AB should be equal to the corresponding part on the other figure. So AB is equal to DE. So I want you to pause the video and just fill in the blanks right now before I fill them in. Okay, so AC is going to be equal to DF. BC is going to be equal to EF, angle A is going to be equal to angle D, and angle B is going to be equal to angle E, and finally angle C is going to be equal to angle F. Okay, so actually I want to talk about this now. How do you prove that two triangles are congruent? How do we prove two triangles are congruent? So, do I have to show that all the corresponding parts are congruent? No, not necessarily, even though that would be an ideal way of doing it. We prove that triangles are congruent by using one of these 5 postulates. So there's 5 ways to do it. We can use the side postulate, the side angle side postulate, the angle side angle, the angle side, or the hypotenuse leg postulates. So these are all postulates. They are all ways of proving that triangles are congruent. So let's just break down each one. So the side postulate says if the 3 sides of one triangle are congruent to the 3 sides of another triangle, then the 2 triangles are congruent. The side angle side postulate says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. When it says included angle, here's what that means. The included angle would be the angle that is in between the congruent sides. So you see this angle C over here, it's in between the side that has the tick mark here and the side that has the tick marks here. So included means it has to be in between. So angle D is also the included angle on triangle FDE here. The angle side angle postulate says if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the 2 triangles are congruent. Now this time it says included side, so it's the side, so the side has to be in between 2 angles with the marks. The angle side theorem says if 2 angles and a non-included side of one triangle are congruent to 2 angles and the corresponding non-included side of another triangle, then the triangles are congruent. And finally, the hypotenuse leg theorem. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So we use hypotenuse leg theorem only for right triangles. Please keep that in mind. All right, so let's do a couple of these proofs and then we'll conclude. So it says given RG is congruent to RH, GS is congruent to HS. Prove that triangle RGS is congruent to triangle RHS. So we are given that line RG is congruent to line RH. So these 2 lines are equal to each other. And we're also given that GS is congruent to HS. So I'm going to write that as my statement. And the reason for writing that statement is that this information was given to me. So I have to be able to justify my statements. Okay, now let me explain something to you about these two triangles. These two triangles are sharing a side RS. Do you see that? All right, so think about it like this. If I were to just split these triangles up, if I was to take the one on the left and just split it from the other one, this would be R, this would be G, and this would be S. So just stay with me for a second so I can illustrate this point. And then I was also to break this one apart and bring it over here. This point here would be R, this point here would be H, and this one here would be S. Now look, keep in mind, we already said that RG is equal to RH, and we already said that GS is equal to HS. Now what do you notice about the side that's left here that was shared? RS and RS. Well, they have to be equal to each other, because it's the same side on both of the triangles. Does that make sense? So let's bring that back. So since you have a shared side, that shared side is equal to itself. So we could say RS is equal to RS, and that's called the reflexive property. So finally, we could say, look, these two triangles must be congruent to each other because of the side postulate. If you go back to the postulates, remember we said that if three sides of one triangle are congruent to the corresponding sides on the other triangle, then those two triangles are congruent by side. By this postulate here. This one here. If the three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. And that's what we just proved right now. Okay, let's look at another one. Given BD and AE bisect each other, prove that triangle ABC is congruent to triangle EBC. All right, so first, let's look at the piece of information that we're given, and let's use that information to make some statements. So it says BD and AE bisect each other. So what does that mean? Well, look at the definition of a bisector. Go back and look at it. It means that these lines are intersecting each other at their midpoints. So C is a midpoint of AE, and C is the midpoint of BD. So since C is the midpoint of those lines, that must mean that BC is congruent to CD. And since they bisect each other, we can also say that the other one, AC, is congruent to CE. And what's the reason? Well, we were told that BD and AE bisect each other, so we're going to write that as our reason. That's why we could say that these respective segments are congruent to each other. Okay, now, we can also say that angle ACB is congruent to angle ECD. And here's why we could say that. We're talking about these pairs of angles here. They're congruent to each other. But the reason is because they are vertical angles. And vertical angles are congruent to each other. Now finally, we could say, look, these triangles have to be congruent to each other because of the side angle side postulate. So we got side congruent to side, angle congruent to angle, and side congruent to side. That's the side angle side postulate. The two sides and the included angle. Okay, given P is the midpoint of AC, BP is perpendicular to AC, and BP bisects angle ABC. So there's a couple of ways that we could go about this proof. I'm going to start with this one here. All right, let's just start with that. We got to start somewhere. That says that BP is perpendicular to AC. Perpendicular lines form 90-degree angles. So what that means is that this is a 90-degree angle and this is a 90-degree angle. Right? BP is perpendicular to AC. Then let's take a look at this over here. It says that BP bisects angle ABC. So BP is an angle bisector, and it's dividing angle ABC into two congruent angles. So angle ABP must be congruent to angle CBP. And then we were told that P is the midpoint of AC. So that means that segment AP is congruent to segment PC. Okay, now we just have to write our statements down. And it doesn't matter in what order you put them in. So why don't we start with the angle bisector one. So we know that angle ABP, this angle here, is congruent to angle CBP because BP bisects angle ABC. And we can also say that AP, whoops, I was writing AB, sorry about that. AP is congruent to PC, and that's because P is a midpoint. And then we could also say that angle BPA is congruent to angle BPC, and that's because they are both 90 degrees. Now finally we could say that triangle ABP is congruent to triangle CBP, and that's because of the angle side postulate. By the way, if you're thinking, gosh, was there another way to do this? Yeah, there is. You didn't have to go about it this way. You could have also used the side angle side postulate if you decided to use the reflexive property we looked at earlier. So usually with these proofs, there's more than one way to do it. And I encourage you to look into the different methods for doing this one. Okay, so that's it for now. I hope this video helps. I do encourage you to go back and replay the parts that were a little confusing. You could always reach me, and I'll be more than happy to help you out. I hope it helps. Take care.